Succeeding, we are so excited to introduce Ali Arsenjani, PhD. Dr. Ali Arsenjani is the Director of Cloud Partner Engineering at Google Cloud, building strategic partnerships with Google's largest partners. He specializes in AI and ML and data analytics and enabling integration, build and run on the Google Cloud Platform, enabling strategic co-innovation with ISVs and GSIs. He integrates with product management to lead the direction of Google AI and analytics. Previously, he was the head of machine learning, worldwide tech leader for AWS, AI and ML specialist solution architects. As Chief Principal AI and ML Architect, he defined technical strategy for AI and ML services, leading the technology sector for SaaS, software, ISVs, and Internet, AWS' largest customer segment. He created solutions that span multiple scenarios into reference architectures and patterns. Also, Ali led a specialized research team of applied scientists, engineers, and product managers for cutting-edge prototyping and AI. Ali was founder of AI startup Deep Context that provides clients with contextually relevant customer engagement actionable data. He is an advisor to startups and boards of larger companies. As Vice President of AI and ML at 8x8 Cloud Communications, Dr. Arsenjani was responsible for defining strategy, research, direction, product management, and implementation of AI and ML products in telecom sector, focusing on UCaaS and CCaaS products. From 1998 to 2018, he was IBM CTO Analytics and Machine Learning at IBM, distinguished engineer responsible for 6,000 practitioners worldwide, combining research and architectural implementations, leading teams in bespoke ML and analytics solutions. Ali built teams globally for large-scale solution development. He is considered as the father of SOA. His career spans CTO responsibilities for SOA, BPM, RPA, analytics, AI and ML systems and solutions. Today, Ali will share his best practices on increasing organizational maturity by adopting AI and ML through the end-to-end lifecycle for increasing business value. Welcome, Ali. Stage is yours.
Thank you very much, and greetings, everyone. Happy to be here with you and discuss with you how to leverage AI and ML throughout the life cycle in order to increase organizational maturity and add business value. To do so, let's look at some of the state-of-the-art capabilities that are there. As you can see, Google has been very instrumental in implementation of several of the technologies that have been essentially critically important to the progress of data analytics and AI/ML all the way through MLOps. If we look at the essential path here, we can look at everything from Hadoop all the way to the different products to TensorFlow and beyond. I'm not going to go into a whole lot of detail on this one. You can take a look at that at your leisure. But with a great number of researchers that we have within Google in general, Alphabet in general, Google specifically in terms of DeepMind, Google Brain, and other research areas, we tend to contribute to open source efforts and keep the industry moving forward along with our other colleagues and our other partners. For example, a very specific area that I can focus on is this area of neural architecture search. That is an area that has been going on since 2016. This helps discover model architectures while optimizing for performance and efficiency. And this has been used in many of our customer situations and engagements and with partners in order to search the space that a neural network has been optimized for. If we look across the industry, the use cases that span these industries span a variety of use cases. We have various mechanisms within retail, healthcare, financial services, and so on. And I've just listed some of the use cases here for AI/ML. And this basic capability that we have is designed to enhance the capabilities of that industry. So, for example, with telehealth and hospital impact forecasting and statistical and biomedical data analytics, this advances healthcare in general and does not only a technology service, but a public service as well. So we who are all in the areas of data and analytics and AI/ML have a responsibility to the public, an ethical responsibility to the public to utilize our data, data science, machine learning, and artificial intelligence capabilities based on a set of ethical principles that we adhere to use it for positive human results and strive to prevent or minimize any kind of risk for adverse effects that may be side effects initially unknown with using AI/ML. As we look across what a company can do or a portfolio of companies can do, we encounter a digital innovation spectrum that spans multiple vertical areas. If you imagine this to be in a company, maturity evolves with the ability to traverse this digital innovation spectrum. You start out with a specific part of the company, let's say marketing, focusing on a data warehouse. Perhaps your engineering organization focuses on a data lake, and maybe your sales and marketing focus on predictive analytics, and so on. But as you within your company would like to increase the capabilities, increase the number of the use cases that we had mentioned earlier, and add additional business value, you will tend to go across this spectrum. It doesn't necessarily mean that everybody has to be at the very end here at an edge device or anything like that, but it's important to recognize that you need to span this digital innovation spectrum and weave together these different areas of functionality using the best practices from data analytics and AI/ML in order to empower that part of your business to reach their fundamental capabilities. So for example, sales and marketing, if you're targeting or providing hyper personalization, micro-segmentation in order to reach a very specific audience, of course, machine learning would be helpful in that area of identifying the clusters, identifying the historical context, making those recommendations in a recommender system that would be super relevant in order to turn a lead into a customer, into a subscriber. So these types of things are extremely important, not to look at them as a silo, but as a spectrum that you can achieve greater maturity as you move from the left to right. There was a study published in 2017 about some of the top-ranked challenges that AI affords within an organization. So within an organization, we have sets of different roles: software engineering roles, data science roles, machine learning, and MLOps roles. A lot of time, these roles are not quite connected as they should be, because at the university level, the training that each one of these job descriptions often get are different. And the difference between them causes a slight dichotomy. So marrying together, integrating together machine learning / data science with traditional software engineering is extremely important. Here, we're just talking about the importance in this. As I reviewed this article, it talks about the relative experience rank of the different roles that perform these types of things, like making data available, collecting the data, cleaning the data, managing, etc., all the way to model evaluation and deployment. So as we go through these different roles, it's extremely important to recognize the intersection and interactions between these roles, which are currently very siloed in organizations. One of the things that I would like to leave you with today is to think about how you can achieve higher levels of maturity using the AI/ML lifecycle or within the AI/ML lifecycle. And we can do that by essentially answering a few questions for ourselves. For example, what we can do is we can basically take a look at, as a team, has the machine learning and data science goals for use cases that you've explicitly defined? So first of all, have you defined those use cases within your organization that ML will be applicable to? And if so, what are the goals that you've defined in terms of the fundamental aspects of machine learning? The clustering, the classification, the regression, the forecasting, the recommendations AI. What are those types of capabilities that you have defined in terms of use cases of machine learning? And the use cases of machine learning, as we saw earlier in that previous slide, are broad topics that are industry focused. But ultimately, if you break them down, it has to do with clustering, has to do with classification, with regression, with recommendations and forecasting. So have the teams defined these goals. And thank you for taking these polls. It's important for us to collaborate in this and look at these. Or for example, secondarily, at a second level, we can take a look at, for example, the second level of maturity here. And at that second level of maturity, is your team applying the entire life cycle for machine learning, the entire ML process, along with these different phases of data cleansing, of feature store, ingesting, selecting an algorithm and training, evaluating the results, explainability, and then going into hyperparameter optimization, deployment to an endpoint, monitoring that endpoint, having a pipeline that will be able to go all the way back if you detect some drift and do this all over again. So this kind of a maturity in adopting these, is your team applying this process with all these phases in a consistent manner across the organization? And we have to be very candid with ourselves and take a look at essentially these types of results. The third layer is to actually have a documented reference for activities within the lifecycle. So do we have those documented references for each of these phases? What do I do in a phase? What is data cleaning? What is data prep? What do I mean by data preparation? Is it it's standardization, it's normalization, it is getting rid of nulls, it is enriching the data, it is maybe entity resolution, and potentially enriching the data with additional data, and then ultimately putting it in a feature store somewhere where you have a gold standard within the organization where you can actually call upon the data and not wonder, did I actually clean the data? Did I normalize it? Did I standard? Oh, who did this? So you have a go-to place within your organization, a feature store, a virtual repository where you put all that prepared data so that it's a gold standard and you can leverage. And then at the fourth level is whether you've actually been able to automate these tasks. So is it the case that your team has most, if not all, but some or most of these tasks automated? And is this automation something that the tools and the underlying capabilities, maybe on-prem, maybe in the cloud, maybe a combination, maybe across multiple clouds, have we automated these sets of capabilities? And are we in a place to leverage automation in order to facilitate the use of machine learning within each one of these phases? For example, let's say you've trained your model. Can you now put your model in a model registry in an automated fashion? So everyone can look and say, okay, this model that was trained actually goes back to what lineage of data? What did I do to the data that, and which algorithms I selected? Which experiments did I run in order to put it into this particular model registry? And then at a level 5, are you measuring, tracking activities, and retrospectively recognizing these bottlenecks? And lastly, is the team doing some kind of a continuous improvement? Are you using the data and the tracking and using a data-oriented approach, applying new learnings to improve the ML process so that you can achieve greater and greater maturity within the use of data analytics and AI ML to achieve business goals? So these are the questions you will need to ask yourselves, your vendors, and different teams in order to see where you are. And you can do this periodically to assess your progress. But I am going to focus on something slightly different, on the actual modeling phase, the training phase. How can I get better results, better accuracy, precision, recall, F1, AUC, ROC, these measurements of how good a model is performing? There's a tendency to overfocus on the ML model itself above everything else. And back a few years ago, well, 2017, a number of my colleagues published a paper called The Hidden Technical Debt in Machine Learning Systems. And these machine learning systems are all these other gray boxes around that orange small box that is entitled ML code. So in order for us to take a look at what is going on here, if we only focus on the ML code, we are doing a disservice to ourselves. And maybe as a research scientist, we can focus on these areas, but industrial scale, enterprise scale, business-driven use of machine learning actually requires us to move away from just the code and into these other things, the configuration, the data collection, the data verification, the resource management, the feature extractions, the process management, the serving, the monitoring, the pipelines, the ML registries, etc. And beyond that, to look at the actual personas who are performing in each of these stages of the life cycle. Product managers, data analysts, all the way to ML engineers, they do different things within the life cycle. So their jobs need to be delineated differently. And it needs to be clear where one ends and another begins. Maybe I'll wear one hat and then another hat the same day, meaning maybe I'm a data analyst and an ML engineer. That's okay. but as long as it's understood within the organization who is doing what. One of the things in that paper, The Hidden Technical Debt in Machine Learning Systems, is something that a lot of people overlook from that paper and just use that iconic diagram that I just showed you. But there's a section called other areas of ML related debt that I'll call your attention to, because that's a very important part of the paper that people miss. This is about data testing debt. So if data replaces code in ML systems and code should be tested, then wait a minute, data also needs to be tested and verified and prepared. The input data is critical. So I'll give you an example. You've already deployed a machine learning algorithm to an endpoint. So you're running inference on it. And the data you use to train that model, distribution. If that distribution changes over time and the inference data coming in for inference has a different distribution, you have a dichotomy, you have a shift, you have a drift going on with your data. That difference in distribution should call you to actually start retraining your data. The second aspect is reproducibility of data. It's important that we rerun experiments and get similar results. We don't do that often. Once we get good results, we sometimes move on, but to rerun experiments with different types of data in real-world scenarios is extremely important. And then thirdly, from a process management debt perspective, there's a problem of updating configurations for similar models safely and automatically, and how to manage and assign resources among the models with these different business priorities, so you can visualize and detect blockages of the flow of data in production pipelines, in your ML pipelines. These three elements of hidden technical debt in the other areas are extremely important to enhance your maturity in AI ML. And the last one, which is maybe one of the most important ones, is the cultural debt. Creating team cultures that reward essentially deletion of features, reduction of complexity, removal of debt, tech debt, improvement in scalability and reproducibility, meaning reproducibility, the previous one, which is rerun your experiments on different types of data. And monitoring to the same degree that where improvements are valued. And the dichotomy I described in terms of the dichotomy between data science and software engineering, for example. So to enhance your digital transformation strategy with these data analytics and AI ML set of capabilities, we need to understand what are the building blocks, what are the ingredients across the ML lifecycle. We already looked at the personas, we looked at the maturity factors, we looked at the hidden technical debt. Now let's look at these key components and ingredients. So in an integrated data to AI journey, we need to actually have some sets of capabilities that are helping us with data engineering, data analysis, model development, engineering, and activation of insights. On the Google Cloud Platform, we have a number of products that help us do so. And we've highlighted it here. BigQuery is our analytics tool. Vertex AI is our flagship AI ML managed set of capabilities, and so on. I'm going to highlight three generic things. You need to focus on features which relate to data. You need to put them in a feature store. But in order to even ingest them, you need a data lake in order to ingest them into and process them into a feature store that's a reliable gold standard. That's getting the data house in order. Next, we need to be able to track, train, and run experiments so that we can actually have models that are one in hundreds, maybe, of experiments we run and are happy with, versus the other ones that don't run as well and don't get such good results. So we need to look at another factor of interpretability, explainability, fairness, and bias reduction in our models and in our data. Once we're happy with them, we deposit them in our model registry. And lastly, when we deploy our models to endpoints, we need to be aware of creating automated pipelines and automated monitoring techniques so that we can rerun our training or rerun our data pipeline, rerun our experimentation or hyperparameter optimization, or rerun the entire thing end to end. So these things are important. Remember the features, remember the registry, and remember the endpoints. And these are control points from a governance perspective within your ML organization and allow you to track everything and gather data so that you can improve. So to summarize it, you have your data, your models, and your lifecycle itself. I'm looking at it from a slightly different lens, which is data requires data lake ingestion and data prep. Data ultimately requires, after that, featurization, experimentation, and explainability. Models require training and optimization, and ultimately depositing into a registry. These models are served but need to be monitored constantly so that you're not relying on some result that is coming out when your data is no longer valid or the distribution of your data is no longer valid. And ultimately supporting the life cycle through pipelines. Automated pipelines that does a part of this life cycle or it's the life cycle in its entirety. So these are the detailed components of our ML journey. Understanding where the model is coming from. It could be coming out of the box with pre-trained APIs and models. It could be built with custom AI models, auto ML models, or in place in our datasets, in our BigQuery datasets, for example, in our data warehouse. This is the Google data warehouse called BigQuery. Each company has its own different moniker for the data warehouse. BigQuery has the capability that you can actually provide ML inside of BigQuery with just a SQL statement. If your persona is a data engineer and you do not wish to, for example, externalize it in Vertex, you can do that. Or you can externalize it and run custom models. And then the end-to-end AI ML tools that allow you to deploy custom models to the edge and or build custom models. The second dimension is where the data is. You can spin up Vertex AI workbooks, which are Jupyter notebooks, to do your experimentation, and then run them through scripts in an automated fashion to take care of your data, analytics, and ML, do any kind of processing via Spark, via other kinds of capabilities that we have, and then deploy them in a registry with metadata and pipelines. This gives you a unified interface for data analysis and AI development and on Vertex AI, and a continuous, consistent flow of minimal data movement. If you don't need to move the data and need to run very basic algorithms, you can do it directly inside of BigQuery, essentially our data warehouse. MLOps tooling exists also across the board for BigQuery and Vertex AI. There are a number of Google Cloud AI and industry solutions, such as Contact Center AI, which handle virtual agents, conversational agents, and key AI and data insights for your contact center. All sorts of document processing with Document AI, recommender systems and search for retail and media, and then healthcare insights. These are pre-trained AI solution suites based on industry solutions. And then, of course, these are all based on our pre-trained models for speech, vision, translation, language, and structured and unstructured data on top of the Vertex AI platform, which gives you the notebooks, the training, the prediction, the MLOps, etc. So let's look at the feature store as a very specific item. Let's say you have these pre-trained models, and you can leverage these pre-trained models for vision, language, conversation, and structured data. You can leverage them in terms of the data set themselves inside of, let's say, a BigQuery data warehouse, or you can externalize them. You can run AutoML capabilities, and you can have various types of insights on time series, on tabular data, and on various types of image, speech, and multimodal types of data, NLP-based data as well. If you look at the Vertex AI platform, there is a top level of AutoML capabilities, which gives you all these capabilities for vision, language, forecasting, etc. A data science toolkit where you can spin up a workbench and manipulate data, and integrates very directly with data services such as cloud storage, BigQuery, BigLake, which is our data lake, and business intelligence capabilities. And then there are custom workflows where you can run experiments. And one of the fundamental aspects of doing ML is the ability to run experiments and track experiments. What happened to the data? What algorithm was applied to it? What manipulation was applied to the data? How was the data enriched? And to store those experiments and pick one to train. And this is the neural architecture search that I spoke of earlier, which helps in hyperparameter optimization. I've done 200 models. Which one is the best? Let me automate the process through neural architecture search of picking that. Or let me do hyperparameter optimization using a product we call Vizier. And then they're in the deployment for prediction or a matching engine capability for deployment that is there. This rides on top of the capabilities around pipelines to automate different parts of the process in a workflow. As we monitor the data, provide explainability, look at the metadata, the feature store in the model registry. So the first component we talked about was a data lake. So Big Lake is our data lake, which is a secure governed lake. You can span multiple different clouds and gather data from these different clouds into Big Lake. There's self-serve analytics, and there's interoperability between it. It basically expands BigQuery and allows you to take into account Spark, TensorFlow, Presto. You can have Parquet, JSON formats. You can access cloud storage on Google, on Amazon, or other sets of capabilities like Lakehouse managed tables on Iceberg, and have the metadata sitting there in BigQuery. You can run various types of queries on that. So Big Lake can be this surface to ingest all data from all places. And you can do various types of governance around it with Dataplex. Dataplex is our governance platform on Big Lake. And you can transition data from one format to another, ingest, manipulate, and prepare it for training. We also have this thing called the Analytics Hub, which allows you to share data as a publisher to a consumer or a subscriber using an exchange with lists. Let's look at the feature store as the next component. So looking at that feature store, feature sharing is used across different use cases. A column of data, a feature of data used across multiple use cases. Let's look at the hypothetical online retailer. They have an entity type called user and a feature called spend over past week, which is the sum of the dollars spent by each user over the past week. Let's say you apply various algorithms to it. This feature will be available in multiple use cases, in search ranking, in fraud detection, in email marketing. You need to actually leverage this one field, this one feature across multiple use cases. So the idea is to insert it into a feature store after it's been cleaned and prepared so everyone can use it. So you can use the Vertex AI feature store for this ability. This allows continuous training, experimentation, integration with CI/CD, and serving and monitoring. Let's look at the components 3 and 4, which are experiments in the model registry. So you want to be able to manage all these experiments that are happening in terms of managing the models. The experiment produces a model. The experiment takes data, uses different algorithms, different hyperparameters, produces a model. You want to have this list available. You want to have an API that can access it, and you can put it in a model registry so you can access it in a unified data platform that combines data and AI together. If you don't need to move the data, BigQuery ML provides you with the ability of running all these different types of algorithms for classification, regression, model operations, and clustering and anomaly detection and time series in the database, in the data warehouse itself. And if you need to move it, and if you, for more mature applications, you can use the Vertex AI workbench in order to actually move it out, enrich the data using Spark, for example, a combination of Dataplex, Dataproc, and Dataflow, and mature the data and put it in a place where you can leverage. And then lastly, the ML pipeline itself, so that the training, experimentation and retraining, iterations, and the serving with model deployment and monitoring are integrated together in a governance framework. So you have an end-to-end MLOps capability with Vertex AI pipelines. This gives you the ability to cut across all this data exploration, creation, training, evaluation, comparison, deployment, and monitoring capabilities with one interface, which is a unified interface. This is the automation of those capabilities that we talked about in terms of maturity earlier on. And it helps you simplify ML ops using Vertex AI pipelines. When you're monitoring these capabilities and putting them in a registry and storing them in a feature store, looking at their metadata over the life cycle. And importantly enough, we need to make sure that we remember that we need to be explainable with our AI so that we take a look at why the model produced a certain classification or regression number, a certain decision. Before we make that decision, we can bring a human in the loop, look at the explainability factors, and make an ultimate decision. So Google's difference here is that we are leveraging a very strong ecosystem of our partners. We're very inclusive in that. We have over 800 ISVs. We have a Data Cloud Alliance and hundreds of technical integration partners that use our various products and capabilities. We have a program, if you want to take a snapshot of this QR code, it'll give you a form that you can fill out and inquire about this program if you would like to be a partner working with our Built with BigQuery program. This Built with BigQuery program gives you access to technology, access to expertise, and marketing along with Google Cloud in order to have this integrated end-to-end journey. So I'm going to leave you with the idea that maturity evolves as the ability to traverse the AI/ML digital innovation spectrum goes forward, picking the best tools for the best part of your organization that needs those tools. And as you move to the right and increase your capabilities around AI/ML, you're able to integrate these capabilities not as silos, but as a continuous digital innovation spectrum. And please remember the governance points, which are the features in a feature store and data lake, the registry for model registry for storing experiments and explainability of AI, and the pipelines that allow you to manage the endpoints, monitor them, and retrain and recreate the automation around the process. With that, I thank you for listening in today.
Awesome. Thank you so much for that very, very insightful keynote speech, Dr. Arsanjani. Basically, I have a lot of questions I can see in the participant, but before I do that, I would like to first thank you for giving us that wonderful keynotes. I have some question here. Today's topic is so meaty. Organizational maturity by adapting AI, ML through the end-to-end life cycle for increasing business value. So we're going to break it down one theme at a time. Let's start with organizational maturity and how that plays a role in technology architecture decision. No doubt our audience is as curious as I am. Should smaller companies embrace enterprise architecture concept like being service oriented as early as possible? And if you would, please provide our audience with a little context around SOA first.
Are these one of the questions in the submitted questions? I just wanted to read the question, look at the text of the question if possible. Is that okay?
Sure, no problem, Dr. Arsanjani. You can go to the participant, you can click that.
I'm there.
Those questions.
Me to take the one from the top, or how would you like to?
Your choice, Dr. Arsanjani.
Very good. So I'm going to look at some of the top questions. How do AI infrastructure qualified sets of data in different... Busa Catherine is mentioning how do AI infrastructure qualified sets of data in different platforms can be utilized for results. How can organization help its stakeholders understand the business value or effects of AI infrastructure to create streams of revenue or lower the operational workforce cost? Well, to understand the business value and effects of AI, we need to define small pilot projects, define value at a small level, and then gradually increase in iterations. As the use cases are important for the organization, start with there, demonstrate the cost reduction and expansion and scalability, and ultimate cost saving. If it's not an immediate cost saving, it's a medium long-term cost saving. But you need to start small and build that infrastructure upfront so you demonstrate the cost savings. Joel, you mentioned a question around SOA in your question, and I was processing that in the back of my head while I was answering this one. If I got the question correctly, it's how soon should we start adopting SOA pretty much within the organization if we're not a very large enterprise? And I would say that the mindset of creating a service-oriented architecture is about defining initially what your goals are, and based on those goals, what are the services that your company provides to fulfill those goals? And there'll be a large grain service. Then you can break that large grain macro service down to smaller services, microservices. And that breakdown allows you to have a catalog of services, a hierarchy of services called a service model that you can then leverage. You can pick some of those services, implement them in regular code, like any software engineering would. You can pick some of those services that have to do with clustering, classification, regression, forecasting, and recommendations, and use ML and data science to support those use cases. So think of SOA as a lens into structuring a catalog of capabilities for your organization so you can evolve into higher levels. You can evolve into an enterprise. No matter how small you are, if you're a two-person startup, you can apply the same principles and structure your thinking, define your goals, start with the goals and work backwards to the services and microservices that support them, the data that each of those services need, and then determine which of those services are functional, which are ML based, and move your ML digital innovation spectrum progression from there. I'm going to take questions until you stop me, Joel. So
Go ahead. We still have like less than 6 minutes.
thank you. So I'm going to take the second one or the third question here that I see on the top. Charles Daniel is saying, I apologize if I'm not saying your complete name. I'm trying to be quick. How can you convince entrepreneurs or businesses to use and apply AI? I would not convince them. That's a non-starter. I'm not going to try and convince anyone to use AI. I'm going to try to convince people, do you want to be successful in this use case? And do you want to be fast? Do you want to be reliable? Do you want to be efficient? Do you want to cut costs on this use case? If so, I will implement it for you. This is me speaking on your behalf here. So I would not try to convince people of using AI. I think that's the wrong question to answer. The right question is, What do they need to do? And can AI solve that? That's an internal problem. It's under the hood. What kind of engine is in the car? I just need a fast engine or an efficient engine or an electric car that doesn't have emissions, let's say, and it can go so many miles, let's say, or so many kilometers. So follow up on your question, especially when AI machineries are costly and require high resources, I would say, quite honestly, that you can start with open source sets of capabilities. TensorFlow, for example, is open source. You don't necessarily need, and on the cloud, you can have much smaller resource footprints to begin with, and then build up a case like the other question I was talking about in terms of SOA, apply the same principle and increase your spending only when the revenue starts to increase. The last question about considering it's a new industry, there's limited knowledge. I would say that, yeah, people need to get skilled. You need skill there. So there's no silver bullet there. There's definitely skill, and you can hire skill, and you need to pick the right skill. I'm going to go on to the next question. Sherry May Aquino, what advice can you give to startup company wants to utilize AI data digital innovation spectrum, but doesn't have enough money to invest in it? Start small, start with open source. Open source is free. You don't have to pay anyone. You don't necessarily have to have huge GPU devices and train huge, other companies have trained it. Go to all these companies who offer these pre-trained models. Use the pre-trained models, get a viable set of results on open source, and then gradually expand to the cloud of your choice. Google Cloud is one of the companies who offer credits to startups, so you can apply for credits at Google Cloud, and then you can use those credits to train on Google Cloud, basically. And if not, just go open source and increase from there. Apologies if I mispronounce names. Bettina Panique, as data is asking, as data is important in developing AI algorithms, how does Google Cloud help out small businesses move to enterprise-wide initiatives to create that business impact in a short amount of time? So basically, we offer startups credits and support, and even this built with BigQuery program that I just mentioned, that is something that you can definitely leverage in order to get started. This is the QR code again. Next, Rhoda Sonaris, the application of AI/ML in business is frequently assumed to increase market competition. In your opinion, what major risks and issues from the interaction of ML and ML-like technologies are within regulatory agencies? The risks are that the regulatory agencies may not yet be up to par with handling the legislation that takes into account ML, but they're catching up. I know in North America, Europe, and APAC, Asia Pacific, there are regulations that are being gradually put in place. Laws are being made up to date so that considerations around machine learning and AI are being taken into consideration. Next question, considering the use of AI/ML in the organization. This is Renel John Tormes, considering the use of AI/ML in their organizations and improving business value. How will the scalability of AI/ML across the organization affect across the organization? Will there be sudden change or is it gradual? Definitely the gradual change is, remember, small changes have long-term positive effects. Big changes will cause fractures, so small changes over time. And maybe I think the last question, Michael Sheen Pareta, both AI and ML are paradigm-shifting technologies that are reshaping the world. What is the most significant obstacles in presenting widespread adoption of AI, given it's being used by organizations to boost its skill and myths? You have to have skill and knowledge in order to bust myths. A small amount of knowledge is actually dangerous. You need to enhance the knowledge so that it's not a misconception. So I would say these are the ones there. And apparently we have 50 seconds. Sean Michael, there are enterprises already used in the way they share data in their departments. What will make those users fall in love with this new data paradigm than the old style? Will it the way you'll convince them is, do they want to unlock patterns and activate their data? Do they want to unlock their data, or do they want to keep their data locked within their old guard data warehouses? If you want to unlock the data and make the adaptation possible to unlock new value, new patterns that are latent in your data, then you can do so with this new paradigm. Excellent questions all around. 5 operational challenges in adopting a data mesh architecture. What is this? Okay, these are different. What is the next big thing from Google in MLAI? It's the PALM, PALM model that we have. You can look it up. There are papers published, PALM, PALM models. Pathways language models is what it stands for. PALM, pathway language models. Those are the next big thing in AIML that we've published. How mature is the AIML of Google in terms of technological advancement? Well, we're pretty mature. And thank you very much, everyone, for your participation.
All right, and I guess now is the time to pick the winner of the most thoughtful question contest. Why don't you tell us which one you think was best?
The winner of the most thoughtful question. That is a tough one. I'll pick Sherry May Aquino.
All right, Sherry May Aquino, it will be the winner. Thank you, Dr. Arsanjani, for being with us today and giving that great presentation. I certainly enjoyed it.
Very much for having me.
All right, you have a good evening.